In this video, we're going to be looking at local extremes, but in this question now, you are only given a range where you're supposed to work, meaning you cannot work outside any value that is given within these ranges. So you can pretend as if it's a number line and you're working between -4 to 0.25, and within that number line you're going to go and also consider the x values that you would have found on your first derivative. We know these ones you have to equate them to 0. You will have your 2x is equals to 0. Then you will also have your 2x minus 1 is equals to 0. Then here you will have your x being equals to 0. This one you will have your x being equals to 1 over 2. Then the last one you're going to have your x minus 1 is equals to 0. Then you will have your x will be equals to 1. So for each and every range that you see here, you're going to check if these x values that you got here, if they are falling within the range. We're only having these 3, so you always check if they're falling within the range, and you start by calculating. So how are we going to do this? So for the first one, we're going to say what is our g of -4. So we input -4 into the original function. So here we have the derivative and the original function. In this instance, we're going to be using the first equation because we're basically looking for our y values within the graph, because the graph can either go up, which is going to be a local maximum, or go down, which is going to be a local minimum. So if we input -4 into the original, we are going to get a value of 400. Then we check again, do we have any value that is falling within the range? And yes, 0 is falling within the range. Then we can say we have g of 0. What are we getting if we input 0 into this one? If we input 0 everywhere, we're just going to get 0. Then we check again, we don't have any other value that is falling within this range, so we're going to use this last one, which was 0.25. We input into the original, we get 0.035. so now you come to your final part, which is your conclusion. So you will say the function has a global max at x is equals to -4, x is equals to -4, x is equals to -4, and a global minimum at x is equals to 0. You see, so this is the conclusion that you have to make based on these 3 that you have calculated. So you're also going to do a similar thing when it comes to that one. So since we've solved that one, I'm going to move to number 2. So we get to number 2. On this one, we're having the range between -5 to -1. We ask ourselves what number falls within that range. Actually, we don't have a number because this is just ending on the left hand side of our number line, because remember I said you can interpret this as a number line. We have -5, we have -1, we have 0, then we have the other numbers this side, on that side, you see. But now all our values are ending up to -1, and this side we have the 0, the 0.5 and the 1. So it means we're only going to work with g of -5 and g of -1. So if we input g of -5 into the original function, we are going to get a value of 900. Then if you input g of -1, you are going to get a value of 4. So you go and make a conclusion again that the function has global max at x is equals to -5 and a global mean at x is equals to -1. So that would be the conclusion for that one. So now you have to move to the last one. We move to the last one. We have the range between 0 to 2. So if we input it on a number line, we have 0, we have 2 here, but in the middle we can have what? We have the 0.5 here. We also have the 1 here. Then yeah, we have the 0 itself, we have the 0.5, we also have the 1. So all the values are putting within this range. So it means we're going to find our g of 0, g of half or 0.5, then your g of 1, then your g of 2. So those ones, as we said, g of 0, if we input it here, we're still going to be getting a 0. Then your half, it's going to give us 0.0625. Then for your g of 1, this gives us a 0. Then your g of 2, then this gives us a 4. You see, so now you have to finalize your values. And if you can notice with this one, because you have to check, we are having 2 x values that are giving us minimums. So now you're going to say with your conclusion, the function has a global mean at minimum x is equals to 0 and x is equals to 1. The function has a global maximum at x is equals to 4. And that's it. That's basically how you solve this type of question. So one thing that you just have to remember is that if they give you this original function and they just tell you to find the global extremes g, you know each and every time when you're working with your global extremes, you work with your first derivative. So in this instance, they had already given you your first derivative and already simplified it for you. So you just had to write down the values, then consider them within these 3 ranges that you have done. If it's still confusing to you, you try to use a number line to make sure that you are not missing anything in between. So see you in the next video.